unless you have been living under a rock, you would have noticed that the new ChatGPT model O1-mini is actually available without you having to register. Yeah. Now let's try to ask it if we can solve quantum mechanics and gravity and measure them. Okay, not there yet. We'll wait for O1 full. Now, in other news, Anthropic has released a new way to be more accurate regarding RAG, which is Retrieval Augmented Generation, announced by one of their guys working on Claude. So they use something called Contextual Retrieval. So it makes sense if you think about it. And it actually decreases error by 67%. And then because we actually add to the chunk, we actually need something to decrease the costs. So tada, Claude has prompt caching. Now let's look at an example. Say you want to change your password and you're going to your company's internal system and say, how do I change my password? Now in standard RAG, the AI system will retrieve data from the internal API, get it to an embedding model, which are small language models like Claude Haiku and OpenAI O1-mini. We add the embeddings to a vector DB, and when a user prompts, the embeddings are sent to the LLM, and then the LLM gives an answer, which is wrong for large context because it does not know which system the password changes for. Now in contextual retrieval RAG, the AI system, after the data from the internal API is converted to embeddings, those chunks of embeddings have metadata of the context. So that context is generated by a small language model and not your web app. Elephant in the room. Doesn't it create more tokens, which equates to more money? And they're just milking us of money here. So the trick is that the prompt caching that they have in Claude will actually store in memory responses from certain prompts. So it doesn't have to count it as extra tokens. It's still more expensive though. It's a trade-off of expense for accuracy. So let's look at prompt caching in a silly example. Let's say you ask whether cats are cooler than dogs, and it'll think, and the LLM will say yes. And then if you ask it again but add some context, the cached prompt response and only work with the extra context. This can lead to retrieval errors, especially with complex information like financial reports or technical documents. So this new technique does what the normal RAG was doing, which is retrieving the data. And then after creating embeddings for it, each and every chunk of the embedding, we prepend another piece of data, some metadata of context. And that context is actually generated by a small language model. So this is how it looks. In a diagram, we spoke about this. The original chunk is the company's revenue grew by 3% over the previous quarter. Now with this new technique, it'll mention the company, it'll mention which quarter it was, so that's critical information. So the LLM will actually be more accurate in its responses and will definitely hallucinate less. So even the retrieval of embeddings are improved 35%, and with some techniques, we get the failure rate to decrease by 67%. So yeah, this is just to summarize what we mentioned. Use a small model to generate the context, prepend the generated context to the different chunks, and then in the retrieval step, use the combination of contextual embeddings and contextual BM25. This is just a drawing showing what we just mentioned. It only costs around $1.02 for 1 million document tokens. Claude 3.5 Sonnet. Do you know what contextual retrieval RAG is? Okay, let's check the knowledge cutoff, April 2024. So how does it know? So how do you know contextual retrieval RAG? I made a mistake in confidently discussing a topic that I cannot verify was within my knowledge base. Now for kicks, let's try to make it to draw contextual retrieval RAG. See you in the next video.